appreciate it. All right, so Mike Burrell's gonna watch the chat for me, so thank you so much, Mike. Welcome, everybody, and those of you also jumping in from Zoom. Mike is going to watch the chat, so if you have questions along the way, don't hesitate to put it in the chat, and I'll try to address it. Also, we'll have time at the end for questions. So, how many institutions, before I even get, let me just say who I am. I'm Sharon Marcus. I'm one of the co-conveners for the Reporting Safe Portfolio, along with my wonderful compatriot Scott Perry from the University of Chicago. I'm from Cornell University, and we are on the bleeding edge of the technology at all times. I've known sort of masochism, so we started on portfolio pretty early. So the great thing for you is that we have a lot to share about it. So we're at an hour in here. So I have quite a bit of material to go. And don't worry, going from LDP to Metadb is not an emergency situation. We actually have had a lot of experience with it at this point, and so there are a lot of folks who can help you out, and it is doable. How many folks are in LDP right now going to Metadb, trying to prepare for that? Okay, so we have NLA and Missouri. Leah, of course, I know. Okay, and also Missouri is, as I understand, Jayla has joined us from Zoom. And also you?
I'm from Michigan State. I'm not sure what we're doing. I'm not the reporting person. I just got to gather information.
Okay, welcome, Spartans.
Yes.
I'm actually Wolverine, so I should not say that.
Oh,
But I'm sorry. I'm sorry. Sorry. All right, welcome. So we're going to talk about Metadb. Wesley College. Okay, great. Lynn, thanks for joining. Okay, perfect. So you're going to get a lot out of this, hopefully. And also just don't hesitate to ask questions. Okay, yeah, you can learn about Metadb here as well. We'll be talking about that for sure. Okay, great. These are just popping up. That's interesting. Okay, so we'll be talking about what Metadb is. There's some LDP Metadb basics to understand the changes when you move between those two things, and also what are the advantages of doing that. There's some really great enhancements with Metadb in terms of the technology, the way that it's written to use your computer infrastructure for servers. And so there's a lot of benefit to moving to Metadb. LDP and Metadb schema structures and tables. That's the big change for the reporting user, is understanding how these tables are organized. And I'm going to show you the logic of it so that you can definitely do knowledge transfer from LDP to Metadb easily. I'm going to show you some examples of revising SQL queries from LDP to Metadb, literally, so you can see that. Just very basic stuff. And we'll have some time for some questions. So Cornell, what have we been doing? So we went live portfolio in 2021, and we went live, I'm proud to say, with our folio application server and our library data platform server simultaneously. So that was took a lot of effort, but we're really happy to be in the new system. EBSCO provides hosting services for our application database and for our library data platform, and also our Metadb test instance. We're in the process of converting a lot of queries. We have over 300, and the number just keeps growing. And about 20 Tableau dashboards we're converting also from LDP to Metadb. I'm just going to talk about queries here. If you want to know more about Tableau, just ping me on Slack and we could do a meeting or what have you. But that's a different process. Not everybody's doing that. So we're going to focus mostly on query. Cornell is going to move to Metadb for production reporting services and will retire to LDP in November 2024. So coming right up. So what is MetaDB? So that's the next evolution of the LDP software that runs our reporting database system. So, LDP and MetaDB are data warehouse, like data lake, like systems that copy data over from Folio, take data and ingest data, and from your Folio system so that you can use it for reporting. MetaDB is really similar to LDP, and it was the logical next step in developing the software. Good news, everything you know about your LDP will apply to help you understand your MetaDB environment. LDP, so LDP does extract, transform, and load data from Folio over to your recording database overnight. So when you're working in LDP, you're working with yesterday's data. Some data elements have to be extracted into columns using derived tables. We'll go over that. And that's done by the Folio reporting communities who make the derived tables. In MetaDB, your ETL happens continuously in near real time. And some of the data elements must be extracted into derived tables. Most of the data elements are extracted into columns. And for those of you who are writing queries, that makes it much easier to work with if you can see the data in a column in your table in the database and kind of take a look at it as this is exactly what I want to bring into my query. Much easier than looking at it in a JSON data array, which we call the data blob. And so a lot of focus of the software development has been in extracting those JSON data array elements out into columns so that we can see that. There is a plan in place, as I understand, to extract all the data elements into columns from the JSON. And we have Mike Roth here from Index Data, so if you have anything more to say about that, feel free to jump in.
Yeah, I can tell you that we've done the initial development of that feature, and we're working on the configuration. The way it's going to work is similar to the way that the operator of MetaDB can determine which tables are included or excluded as part of the ingest. And so we're going to specify certain tables or JSON paths that are going to be transformed completely. And so it's not going to be 100%. You're going to be targeted because there's some tables that you don't really care about, some JSON paths that aren't that important. So if we're not just going to do everything blindly, we're going to have a targeted sort of extraction. Our hope is to have that being tested in October for hopefully an October release. But we'll see how all that testing goes. There are a lot of questions around not so much the quality, in other words, we're sure it's going to work, but the questions around what's the right kind of configuration, how much transformation should we try to tackle as part of a resync? Because the more work you do in transforming JSON, the longer your sync times are going to be, and so we have to try to find the right balance on that. So that's where a lot of our testing is going to go.
Thank you so much. That's Mike Burrell. He is the project director for LDP MetaDB. So thank you so much. That's great. So the more extraction, the better as far as a reporting user is concerned. So that's great. The one point here, the MetaDB uses a different organization of data tables than LDP. It is logically the same, but you'll see how it's organized a little bit more by application and rather just one big public schema where everything is listed as a table. So I'll explain that shortly. All right, so we have the nightly update and then we have live updates into MetaDB. So that not only changes how the data is moved into the database, but also changes what we can query on, because now we can get instantaneous data. You want to understand whether your patron at the desk has overdue loans and run a report and get that data immediately. So very, very nice feature. So these are the rollout plans that we have for Cornell Library. We've been working we were one of the earliest LDP implementers. I believe Lehigh was first. And so we have quite a bit of code developed. How implemented your LDP. Lucky for you, you can jump right into Metadb. But it isn't that bad, so we're pretty good at it now. All right, so we're gonna talk about the table structure. So just like most reporting databases, the data for LDP and Metadb are organized into tables. The tables are in schemas, and you can kind of think of it when you're looking at your tables and your schemas in your reporting database through your reporting application, we use dbeaver. It's kind of like folders and files on your desktop, so pretty easy to relate to. So the tables have columns showing the contents of each data field. So in the LDP, just for quick comparison, if you're there, we have the public schema. That's where you find all your tables having to do with basic library functions, circulation, acquisitions, invoices, etc. Then we also have a history schema that contains historical tables with previous versions of folio records. The folio underscore reporting schema contains derived tables that are created by the reporting community to make it easier to do querying. And a local schema, sort of a sandbox for you to save things on the database. And then access to all schemas is through one LDP user account. On Metadb, it's a little different. We have the folio schemas, instead of one public schema, you have these application schemas. So everything is preceded by an application area. So instead of circulation, you have folio underscore circulation dot say the loans. And listed some examples around that. So everything is preceded in the area where you're going to get most of your data by this folio, some kind of application area dot, and then you've got your table. They're organized very logically, just as the public tables were, so they're easy to relate to. The derived table directory, instead of being called folio reporting, is now called folio underscore derived. So that's where your derived tables sit. Then folio mark records are stored in folio underscore source underscore record dot mark underscore t. So you'll get used to that, but it used to be mark tab in LDP, and now it's this new schema, so you can get at your mark records. Each Metadb user has their own account, has read access to see all the schemas. Individual users are the only ones who can write to their own schema, so you have your own personal account with your own schema. So if you set it up with your user account Sharon, then in my Sharon schema, I can write to that, nobody else can. It's not, we don't have it set up, Metadb is not set up to have like a local schema, as we did with LDP before. So it takes a little bit of use to get with the accounts. And this is to improve security, as I understand. So it's just, something to get used to. Now, I don't know if you folks who are moving over to Metadb use schemas a lot. Cornell does, Chicago does. I won't go into a lot of detail about this, but we use local schemas that have names to give groups who want to work on data things together a place to put stuff. And we also have queries that use these local tables that we put there on the reporting team to make queries run that require that information. For instance, we have our own bid format titles for different areas of book series, blah, blah, blah. At the library, we have our own location names that are longer than what you might get in folio, that sort of thing. We can put a list of that stuff into a local schema and then point to it in a query and show that information to the user. So we have several groups, our automation group, our HoneyTrust group, our statistics group, who use local areas on the LDP Metadb environment in order to do their work. So we have to have kind of these shared spaces. So there are a few more steps to set up your shared spaces. So you want to work with your hosting provider, or if you're self-hosting, learn a little bit more about schemas to get that set up. It is possible, it takes a few steps to get that set up. All right, what are derived tables? So that's just a table that's been created by pulling data from other tables. Why would you want to do that? Let's say you have a gigantic inventory table in your ILS, in your library system. And you want to write queries to refer that. For LDP, the derived tables have been very helpful because what we do is we run that data transfer overnight and we put an inventory table that collects that information. It's there already, so that it doesn't have to be loaded in on a query as well. It speeds things up in terms of performance. The other thing that derived tables do is they enable the reporting SIG to say, hey, we want to put certain kinds of information together. For instance, for purchase order information, we want to tie that with invoice, budget, transaction, all of these things that are related in a derived table so that when we're writing the query, all those joins have to be made. We just have to refer to the data elements that are in the derived table. So the reporting SIG has come together to create these special tables for the community to not only improve performance, but to improve query writing capability. And just simply, so once you start digging in on it, you haven't used SQL very much, you start digging in on that, which is required to do any of this. You'll find that you're really using those derived tables because somebody else has thought about getting all those little pieces together for you. Let's see. Yeah, so those derived tables are in LDP are set up to run overnight. Right now, they only run once in Metadb as well. We're trying to figure out how to make that work in the future, working with index data. Is there some other solution? Certainly, the other thing that derived tables do is they pull data out of the data arrays where they are kind of trapped in those JSON data arrays, which makes it easier to query. As well as those data elements are pulled out into columns, there will be less need for that over time. So we'll see some of the need for the derived tables go away. It's hard to say exactly how many we won't need. Right now we have about 20. Maybe we can get it down to 20 or 30. I have not counted lately. But in order to get that number down, extracting the data out of the data arrays is really going to help us so that you can get at that without looking at a derived table. So this transition to Metadb for now means that your derived tables will only run once. And right now, that's sort of a problem for us to figure out, right? Because if you're going to go to an environment where you have all up-to-date data, yet your derived tables are only updated once a day, then, which is the way it defaults right now, that's a little harder, a little more challenging to work with. Yes.
And so that's one of the reasons we're interested in, and you guys are excited about this transformation because
Yes.
if we can get that done in real time, then we don't have to wait for the derived tables.
Absolutely.
To come along. The other thing is where we talked about having explored this, implemented any of this yet, but the possibility of having different derived tables run at different times.
Yeah.
So if you have some very important derived tables, maybe you could run those, have those updated on a cycle that's much more frequent than just daily. So that's something else that we talked about and are looking at.
Excellent, excellent. So lots of options to explore so you can take advantage of that, always updating the future of Metadb. So, all right, thank you so much. So the nice thing about transitioning to queries, all you have to do for your derived tables is change the name from folio reporting to folio derived. So yay, nice and simple. And just a little bit more about derived tables, which we just talked about. Another good piece of information, You don't need to change the field names in the MARC tables, only the schema and table names are different. So where we were going to SRS MARC tab before, we're going to folio source record, but you're going to see all the same field names. So if you have a lot that's programmed to use MARC, you'll simply need to point it to folio source record. So like the direct tables, that's a simple change. So those are the equivalents on each side, LDP to Metadb. All right, so the Metadb schema for MARC has the transforms the MARC records into MARC records. I don't know if that's 1B or LB, but you'll see it there. And then everything is stored in folio underscore source underscore record dot mark underscore T. We'll talk a little bit more about this as we go, but underscore underscore T, it means that it's a current transform table. So you'll start to see that pattern. So the data has been transformed for that table and it is showing current records. So the MARC transform is done every few hours or so. MARC is a huge data set, so it requires a little bit more special processing. Right. All right, so the folio schema. So in LDP, we had a history schema. And for Metadb, the historical information is kept right along in the same schema with the application area. So that's a change as well. Once you see this structure, it makes, and you work with it a little bit and write a few queries, it starts to, you can change your queries to and find things that you're looking for. Not a lot of people use the history capabilities in their queries, but if you do, it's just important to know that this is available. Most people just are referring to the current records. We have the other piece is that we have the main table, which contains all of the let's go to the chart actually. The easiest way to show this is the chart. Now, this is the chart that everybody hates. It allows you to see the difference between the way data is stored in an LDP table and the way it's stored for Metadb. Now, I didn't include, LDP does have a historical schema, so you would have history here as well, but it just started to be too many columns, so I omitted it. But what's important to understand here is time. So we're looking at just current data. I'm just taking one table, circulation check-ins here. And there are 4 tables. The only one that you need to really worry about 99% of the time is going to here, the current transformed data. So for circulation check-ins, you'll go to folio circulation dot check-ins because it's now under this folio circulation application schema. Underscore T. Okay. What are these other tables? Well, they are there just in case you need to get other data that is available, but may or may not have been transformed or is historical. Okay. So we have the main table, just going over one more, let me use this as pointer. So here's our LDP, and this is just pulling out all the data elements that we see on check-ins, ID, item, all these things. And then if you've worked with this at all, there's a data array that has additional data elements that you need to use JSON extract statements to get to pull into your query. So the equivalence these are all, in the check-in, the circulation check-in tables. But with MetaDB, we have the different flavors of tables. So we have the current and historical data, main table. So that has the JSON elements, a full copy of the JSON record. So everything that's included for check-ins. And we have just the current data, main table. So we can see here that this is check-in __, and then we have just check-in. And then we have the transformed table of current and historical transformed data. I call these the tables with the wings. So if it has a set of wings, __t, __, then it contains all the current, all the historical transformed data. So if you have something that you want to take a look at for counts, sometimes we get into this with our annual statistics. We want to go back into history for the information, how many times did the record change, et cetera, or troubleshooting or what have you. You might need the historical information. So there we have the current and historical transform. Then we have just the current transformed data. And this is the table that you're going to use 99% of the time. We also have these different bonus functions, shall we say, with MetaDB, where we can use these fields like ID, start, and current origin to add more information in our query to give it a little bit more functionality. For instance, start and end are going to give you some date time frames that you can use in a query. __ current you can use. If you have to refer back to a main table to get a data element that's not available in the transfer table. So this is a temporary thing that we have to do, but if your environment requires getting at everything, and we know we get a lot of demands for including information in our queries and are really trying to answer questions for our users, we may need to go back to the main table. And so we can use these features of each of the files in order to filter the information as we wish. I'll show you an example of that that kind of fits in with this. All right. So.
Sharon, just a question.
Yes.
Does that mean in MetaDB as opposed to LDP, every table now increases fourfold? So yeah,
Well, not fourfold, double.
yeah, so like you have current data, you have
Yeah.
in MetaDB, your current historical data, your current data, and you have the two transformed versions of those two things. Is that like a pattern across the entire? All table?
This pattern is across the whole database. Is it something that sort of doubles things in size? I think we have some possible answers to that question in the room. You know, is that increasing the number of tables or?
It does, yeah, and it also increases the total storage.
Okay, I'm not talking about specifically derail conversation there.
I don't know by what percentage it does, and so, I'd have to know sort of how that was in LDP. We did have history and current in LDP, so it would just be adding these main tables, I guess. But I'm not, you know, I'm not, yeah, because here's transformed, historical current and transformed current, so that is LDP. But,
What you're saying is effectively your experience has been, you know, upwards of 90% of your usage is that it's just the current transform data in the table.
Yep.
On the far right hand side, it's only one wing.
__t.
I just want, yeah, I don't know if you call that a one wing table or a two wings.
I haven't come up with a name, but I like the one wing, yeah. Yeah, one wing. Yeah. Yeah. And you can't have the rolling cart. All right. How are we doing? Yeah, okay, that's the biggest hurdle in understanding how LDP and metadb differ is, what are all these tools? So I always try to remind people that this __T version of the table is really what you're gonna focus on 99% of the time. So, yeah, okay, so just showing this to you, in our reporting database, you can see that we have folio circulation. Here's the check-ins table, and there's the main table. So you can kind of see what is this gonna look like when I open it up on my Metadb. And then here is, check-in __T, so that current transform table that you're gonna focus on most of the time. And here they are in, back in the comparison. Okay, so let's go through some, examples, and I think this will start to become, second nature for you. So, again, why do we use these two underscores? You know, here we say ___. So, in order to keep the table names unique, they require to having some kind of, rule, so ___ is the way that they are kept unique from, compared to the other tables. So, you'll see here we have lone __T. Okay, so we'll go through some examples, just an overview of what you need to know if you're going to start converting your queries. Comes down to 4 basic steps. Rename your tables from the public schema to the new application-based schema. Choose the current transform table most of the time, ending in __T. If you use derived tables, rename the schema from folio reporting to folio derived. So that's most of what we're doing. We're doing a lot of testing. We're very lucky that SCO, our hosting provider, has set us up with an LDP and a Metadb instance. So we can have our LDP original query, we write it to Metadb, and then compare results. Just make sure that we've gotten it right in Metadb. And that's been very helpful for our implementation. I would recommend it if you can. It requires extra dollars to have those 2 instances running. We've also requested having production data in both instances so that we get the same numbers. And that's been absolutely wonderful and not easy. So, but I would recommend that if you can. All right. When you're doing that table conversion, the Metadb documentation provides table name equivalents for you. So you just want to take a look at that. There's a link to the documentation, and that will show you the LDP to Metadb conversion, so that you can find it easily. Also, let's just do some examples. So in LDP, we would select account from circulation ones. In Metadb, we would rewrite this table to go to folio _circulation dot lone __T instead. If we wanted to use those bonus features that are available, those fields that let you kind of work with time, and sometimes you need to do this because you're extracting data fields from different things. You could use the ___ current status within that table and write it as true to do the same thing. So where we on the LDP would say circulation loans, in Metadb, we would write a folio circulation loan, use the main table, loan __, but then we would say where CL dot underscore underscore current is true. So we would do the filtering in SQL. So this other way, the filtering is been done for you. So most of the time you want to do that. In certain situations, the data is only available in that main table. And so you need to go back and just know if you want the current is true. So this is an important point. All right. So that is true. Yeah, back to those data elements. All right. Getting current and historical loan records from the transformed loan table. So here again, LDP, we would go to the history schema and get circulation loans. And then in MetaDB, we use the table with links, loan underscore underscore T underscore underscore to get our current and historical information from the folio underscore circulation schema. Using MARC, most institutions use MARC, and so the change is simply in pointing to a different table, not a lot of stuff you have to learn about getting that MARC. So if you have a MARC query, something like this, that's pulling out, this pulls out records in English from MARC tab using the 008 MARC tab field. Then you could rewrite it to simply point to folio source record MARC underscore underscore T as to get the same results. Okay. And again, these are just more examples of the same thing. Okay. So we're going to get current records from instance underscore underscore T, or we can use the current is true to make it current by using SQL. Or we can get the historical records by using the table with links. All right, your derived tables, all you need to do there is change the reference in your from, if you're using a derived table, from folio reporting over to folio derived. Nice and easy. Now, this is a very convenient example because I'm not pulling from other tables, just looking at the folio derived tables. So you often in your from will have, 5 or 6 other tables in your query, but that's just to show you it's pretty simple. All right, and then we have the results for the query. Again, what we do is we check it in LDP, check it in MetaDB, make sure that we're getting the same results after we've rewritten our queries because we have so many. All right, extracting from a data array, slightly different. This is all documented because it's not really, easy to remember. But here, oh, yeah, Kara. Hi, Kara. Do the current values have any use in the current tables? Yeah, thank you. Not that I know of, Kara. We've only used them when there's a data element not transformed, and we have to go back to the main table to get that, but we still want the current values. So as long as you go to the current table, you'll get the current information. So yeah, no, that would be duplicating. Okay, great. Good question. And okay, for extracting from a data array, we have here the language that we use to do JSON the array elements. In LDP, we have this kind of syntax where it's looking at data and pulling out administrative notes. And over in MetaDB, we would go to JSON B instead of data for the data array. to pull out the administrative notes and use slightly different syntax. This is all, again, the MetaDB documentation, that specific syntax. We have lots of examples of it in the derived tables on the Cornell Analytics repository. So, you'll get, after you do 5 of those, you get used to it. And you can also just grab these and try them in your instance to see how that works. So, MetaDB documentation, let's just see how I'm doing, okay. Is available right online for you. Very extensive, really, really good, broken up into just different chapters. This folio section at the end is very specific to what we do. It's, you know, MetaDB is also used for the reshare project. So this is generic documentation for both, but the folio information is down here. And the table names, this, we at Cornell have used extensively to rewrite our queries. There's cookbook documentation. So the Folio Analytics repository is where the reporting SIG and the Folio project keeps all of its derived tables, report samples, documentation, lots of things to help you out. In the wiki, there is extensive documentation, thanks to, I want to give a shout out to Stefan from Leipzig, who's done quite a bit of writing. You know, I've done a little, but he has done most. And we have what we call cookbooks, a term coined by Jem Eustace, if you know her, from UMass. The cookbook is basically a template. You know, here's how to approach this concept in your query so that you can get started. It's really important to understand the data model, and we do get into that in the reporting SIG, so that we can help you, areas of finance, metadata, circulation, they all have their own data model. It's important to understand that as you're putting query together so you're getting the right results. So lots of information here that you can take a look at when you're writing a query to understand more about how to join the tables, the data model, etc. Folio Analytics is right here, and this is where the derived tables are created. SQL is the LDP derived tables. SQL underscore MetaDB contains the MetaDB derived tables. So those are really good to look at also when you're looking at JSON extract statements, which is there are gajillion examples in there, because that's a lot of what it has to do. And CUL Analytics is, we are the cool people, Cornell University Library, and we have all of our report samples online if you want to take a look at those, and just shout out if you have any questions. How did you write this? How did you write that? And we're on all of the Slack lists and everything, so we'll jump in and help if we can. Okay. And just want to shout out to Natalia Piglet, who has been doing the dog cleaning show for LDP and MetaDB with me on Cornell and for the reporting sake, and developed a lot of this material with me. Steve, of course, the original writer of LDP and MetaDB, and Scott Perry from the University of Chicago, my co-convener in the reporting sake, and Oxel Dora, who's been very involved in the University of Mainz. And the Vanzana, Jean, Linda, Jan, and from Cornell University reporting team who suffer through my presentations to make sure they're right. Any questions? Or anything you want to go back to, or, yeah.
So you said the set of queries are maintained by the reporting SIG. Are those on your SIG's wiki pages or are those?
There are links from the reporting SIG to Folio Analytics. And also this presentation is, I have successfully uploaded it, so you can download it from the schedule for WOLFcon, and that has all the links right there. But yeah, we have links to both the Folio Analytics repository. Yeah, sure. Any other questions? or comments or things to add for folks? And anything from the folks on, online? I'm supposed to do spotlight. Spotlight. This is your fully interactive, immersive experience. So we all feel like part of the same thing. It's kind of cool. All right. Any of our online folks want to say anything or ask questions or just say hello? No, just thank you. Okay, you're welcome. Oh, yes.
Yeah, question. Do you find when you're running equivalent queries both in LDP and in Metadb that one of them runs faster than the other?
Ah, good question. Um.
I guess the very fact that you're thinking about listening, so there's not a big difference in either direction.
It depends on the derived table status.
Mm-hmm.
If the derived table is working well, then it is the same. And if the derived table needs some looking at, then we might see some bumps. And then put in a request to update the derived table. So.
But that would be equally true with both LDP and Metadb.
Yeah, we're just focused on the metadb now because we're going in that direction.
Yeah.
We're not focused on fixing the other derived tables too much. I don't notice a difference. Anne, do you notice a difference? Anne is also from Cornell.
Not for the most part, but we did have some Tableau dashboards that now that we have more and more data that we limit it to what we really want to see, not everything. Like in invoices dashboard, instead of looking at all of the invoices, we really just wanted to look at open and reviewed, and it helped it to run faster.
Yeah.
That's where more information wasn't always good.
So again, that doesn't seem to be something to do with LDP versus Metadb, but just the accumulation of more data.
Yeah, I think, Anne, do you think that was kind of just, I think it was also slow on LDP, right? When we.
Yes, I think it's just as you get more and more data, it's combing through everything too.
Yeah, so I think it might have been more of the Tableau, but yeah. Tableau can really quickly, I mean, it's great because it brings in all the data, but it can slow right down. And that's a separate issue. Any other questions? Well, don't hesitate to, thanks so much, Anne. Okay, yeah, don't hesitate to reach out. We can help and, sure your LDP and everything, information will go around. We're here for you.